Now let's look at book 1. And it's exercise 13.6, question 16. The question asks you to differentiate the following: y is equal to 1 minus cos x all over 1 plus cos x, and show that dy dx is equal to t plus t cubed, and t is equal to tan of x over 2. Okay, so let's get going on our quotient rule here. And it gives us dy dx is equal to bottom, which is 1 plus cos x. Diff the top would be minus sin x, which is sin x, minus the top, 1 minus cos x, times the diff the bottom, which is minus sin x. Okay, now that's all over bottom squared, 1 plus cos xt squared. Okay, let's see if we can tidy this up a little bit. It gives me 1 plus gives me sin x plus sin x cos x. These two minuses cancel, so I get plus sin x minus sin x cos x. That's all over one plus cos xt squared. Now on the top line I can see that we'll have a cancellation, because plus sin x cos x and minus sin x cos x knock each other out. So dy dx ends up being 2 times sin x over 1 plus cos x to the squared. Now, the question asks about tan of x over 2. So we need to get from x to x over 2. So we're going to turn to page 14. I'm going to take sin x and I'm going to transform it into an x over 2 density. Now, sin x is rewritten here as sine of 2 times the angle they want, which is x over 2. Okay, so that's where we kick in with our x over 2's. And the same for cos. Cos x is the same thing as saying cos of 2 times x over 2. Okay, so using the double angle formula on page 14, let's see if we can get rid of the sines and introduce tans instead. Okay, so this is separate from our dy dx, so we're just going to rewrite now, get rid of sines and bring in tans. So the sine of 2 times x over 2, the bottom page 14 there, we have that it's 2 times the tan of that angle, x over 2, all over 1 plus the tan squared of that angle. So that's the sine of x. Okay, and the same thing can be done with the cos of x, which is the cos of 2 times x over 2. That is 1 minus tan squared of x over 2 all over 1 plus tan squared x over 2. So using those two things, we're going to introduce now tans instead of sines and coses into our dy dx. So over here in dy dx, we're going to say that two times sine x, which is the top line of our dy dx, is now rewritten as 2 times all this guy over here, which is the 2 times tan x over 2 over 1 plus tan squared x over 2. Okay, so it's 2 tan x over 2 all over 1 plus tan squared x over 2. On the bottom line, I have 1 plus cos x to be squared, so I have bracket 1 plus something all to be squared. Now cos x can be rewritten, and it goes in there as 1 minus tan squared x over 2. All over 1 plus tan squared x over 2. Okay. Now at this stage it's going to be easier just for writing down this to let, as they suggested, let t equal tan x over 2. Okay? Now, if I do that, what happens to my dy dx? Well, let's have a look. dy dx now will be, get a fraction bar here. On the top it's 2 times 2t all over 1 plus t squared. And on the bottom 1 plus 1 minus t squared over 1 plus t squared. That's all been squared. Okay, so I'm going to tidy up the top a little bit. That's going to be 4t over 1 plus t squared, and that's on top of okay, let's simplify this fraction. Let's do a little bit of rough work over here. We can simplify this fraction 1 plus 1 minus t squared over 1 plus t squared is the same thing as saying 1 plus t squared over 1 plus t squared. That's rewriting 1 as 1 plus t squared over 1 plus t squared. We add on this guy, 1 minus t squared, 1 plus t squared. That gives us one big fraction, the common denominator, which is, on top we've got 1 plus t squared plus 1 minus t squared. Those are the two top lines, and a common denominator, so I just write this guy down once, and what happens there is the t squares go. So over here in my dy dx, I'm going to have a bracket being squared on the bottom. 1 plus 1 is 2, all over 1 plus t squared. Okay, move down a little bit. I'm trying to now tidy this guy up a little bit more, so I'll square out those brackets on the bottom. That gets me 4t on top, all over 1 plus t squared still on top, all over, squaring that fraction gives me 2 2's, 4 on top, all over, now 1 plus t squared being squared. It's the bottom line squared out. Okay, now I spot that I can clear the stacked fractions here by multiplying above and below by 1 plus t squared, so 1 plus t squared all squared will clear my fractions above and below. Okay, so it knocks him out, and it will knock him out leaving one of those behind. So what I'm left with is 4t all over, sorry, the 4t times 1 plus t squared all over 4, which is equal to, if we knock the 4's out, with t plus t cubed, and that's what they wanted.